Hello everyone, this is Maseret. If you were watching the videos before, you probably know that I was teaching a Python Basics course. This one is going to include all Python Basics questions, for loops, functions, and classes. Today I'm going to solve 4 questions. These 4 questions are the questions that I asked my students in the first exam. In the description below, you will see 3 files. First one is for the question. Each includes for loops, classes, or functions, or mixture of any of these. The second file is a skeleton. So basically, I gave this file to students and asked them to fill the answers. The third file is the complete answer sheet. I really want to encourage you to download the skeleton. Today also I'm going to do the same thing. I'm going to solve these questions on the skeleton one by one. So you will see on right or left hand side that the real timing of these questions. You can also go to a specific question by just dragging your cursor to that minute. Let's start. This question tells us write a function, insert a list inside this function. It means that pass a list with this function. You would like to observe the print this following structure here. These other lists are obtained by the sum of 2 consecutive numbers. But there is one trick here. It says write a recursive function. Just to remember quickly, recursive means is if you can write fn by using previous variables such as n-1 and n-2, we can use recursion method to calculate the function. So the very simple example, Fibonacci numbers in terms of this, what we want to do right now, you already have the skeleton, and what we want to do, we're going to pass this list inside the function fun, and we want to print all these lists. In recursions, we also have to create a base case. Base case is going to define us where we are going to stop, where we are going to stop calling the same function and again and again and again. Let's create the base case. Base case exactly whenever I have only one element in the list, then I would like to stop. I would like to just return the list itself. So I'm creating my if statement over here. I'm saying if this a list that I'm taking with this function, the length of this is equal to 1, then what I would like to do is just return this a list. Else the length of my list is still more than 1, then what I want to do, I would like to sum consecutive elements and return a new list. So let's say it's called B list. And B list is an empty list. So what we want to do, we can say for I in range len a list. So if I use only a list, length of a list, so I can get out of the list, out of the number of indexes. So what I would like to do, I will keep it smaller so that when I'm adding 2 consecutive numbers each other, for example, when I say such as B list append a list I and plus a list I plus 1.
when I say I plus 1, I don't want to be out of this A list. That's what it is. And then what we want to do at the end of this for loop, B list is exactly going to be equal to the second list over here. And then at the end of this for loop, in this else situation, we're going to return again the same function, but B list. So only one thing is missing here. What we want to print these lists. So if I say at the very top, if I say print a list, first it's going to print this a list, which is 1, 2, 3, 4. Length of the list is not equal to 1, so it's gonna come here because at the very beginning length of this list is 4, and we're going to create an empty list, B list. We are going to add the sum of each consecutive element in this A list to the B list. At the end, we would like to return the same function, but B list inside. So this B list is exactly going to be 357. So when we insert B list and call the same function, this A list is going to be now equal to the B list that we created over here, and then it will print 357, and we will check if length of this A list is equal to 1 or not, which is not. It's going to come again, and we will add 3 and 5, which is 8. 8 will be appended to B list. We will add 5 for the next for loop. We will add 5 and a 7 together. It's 12, and we will append this number 12 to B list again, and we will return the same function with 8 and 12 with a different list, and it will keep going. Whenever in the next iteration B list is going to be only 20, and A list, now A list, when we call one function with 20, now this A list is 20 and the length is equal to 1, so we will return the A list itself. So that's all. Let's try. And over there, as you can see, we generated the exact same representation. In question 2, we have a problem that includes classes, functions, and loops. Basically, everything is in this question. And this is one of my favorite questions. I really like this question. This is a sample of defining a test, and we have students. So each student takes 2 tests, physics and mathematics, and we are generating some random answers for each student. So at the end, we are evaluating their answers. We give them their final score, and we are checking if their score is enough to pass this course. So let's start. You're again going to work on the skeleton. In this question, we have 2 classes. The first class is the test class, and the other class is the student class. So our instances, we have math instance and physics instance. These are the instances of a test class. So each test class takes a course name, answer key, and a pass mark. Again, we define these, let's say, properties for each value we take with this init function. We have already generated mathematics test and physics tests. So right now I am generating an instance of test class, which is called math. And in this class, we have the name of this course. We have an answer key, which is a list of 5 different items. We are assuming we have only 5 questions in this test, and the passing grade is 80%. If a student makes at least 80% of the questions are correct, then this student is going to pass this course. The same thing for physics class. We are generating another test instance, and the name is physics. This is the answer key, and that's the passing grade. So these are something that we are going to use to complete our code. Let's look at part A. It says fill this student list given to you in the skeleton code with 10 student class objects. So what we need to do, we already have student list. So what we need to do to generate 10 students. So I don't have to write 10 times student 1, student 2, student 3. I can just generate 10 student instance with a for loop. So for 10 times, I'm going to generate a student instance, and I'm going to append each student instance in this student list. Append. Now inside the parentheses is empty because init function of the student class doesn't take anything, so just self. So with this code, I am generating 10 student instance and assigning them to student list. Next, in B, generate two different scantrons, one for mathematics and one for physics for each student by picking a random letter from choice list for each question. So there is also a hint, random.choice A gives you a random element in list A. Before working with random, we need to import random module. Let's create other two lists. Let's call them mathematic answers, and that's an empty list. Let's call the other one is physics phy answers, and that's another list. So for each student, then I'm going to I need to create a list, something like this, but this is supposed to composed of by random assignment. So we cannot say like we cannot give the exact same answer. We know one is going to be here, but instead of A, it might be A, B, C, D, or E. All right. So what is going to happen in math answers? This is a list. In the list, I'm going to insert another list for each student. So let's say math answers is a list. Then I'm going to append another empty list with this. I'll do the same thing for physics answers, append another empty list. Now we have 5 questions in each test. So I will write another loop again for loop 5 for j in range 5. What we want to do, we need a string, a number as a string, and we need one of these letters. So what we want to do, math answers I, because we already have it. Let's say I is 0, we append an empty list for math answers 0. Now right now is an empty list, and what I want to do, I would like to append something like a string like 1a or 2b, something like that. So what I want to do, I would like to take this j value and increase by 1. So it's gonna, because we don't want 0 in our answer sheet, everything starts from question 1. So that's a string. If I say plus, like for example, a, this is going to become like 1a, some exactly like this. But I don't want a, but I want a random choice from this choice list. So what we are going to do, based on what is given to me in the hint, random dot choice, and the name of the list, which is choice list in our case, give us a random number, give us a random element from this list. So however, I don't want to keep this like 0. This is going, whenever I is changing, so this is going to also change. One other way to do this, you can always use the last element of math answers, because we are already in this for loop. So both way works. I'll do the exact same thing for physics question, physics answer sheets. This is not an answer key, but for each student we are generating an answer, like scantron for each student, which is, the format is similar to this. All right, so we finished part B. For part C, so we're gonna go up here. It says fill this function for part C. We have a function called, so each student at the beginning, they didn't take any test, so test taken is right now empty. What we want to do, we are going to change this self-test, we're going to change this property, test taken, based on whenever we call this take test function. Take test function takes two different items or objects. First, this test is going to be one of either math or physics. It's going to be a test object, and the scattering is going to be the student's answers. And in this function, we're going to compare the scattering and answer key, which is one of these guys. We have already created scatterings with this for loop, and then now each student is going to take a test. Now for part C, we have to fill this part. Let's say we generate a variable as a string. Let's say result is fail. Let's say result is fail, and let's say score is 0. These are at the beginning. And right now what we want to do, we have the test object and we have the scantron. So for value in scantron, this scantron has the scantron is the answers of the student in one of these tests. So it's in the format of this. We exactly generated this scantron over here in the format of this. So for any value in scantron, if this value also is in the same value also is in test dot answer key, then we're going to update the score, let's say by 20 points. All right, so at the end, if the score is greater than, let's write another if statement. If the score is greater than or equal to test dot pass mark, then we're going to update the result. This fail is going to be pass. All right, and then we need to update one more thing. We would like to update this test taken property. So we're gonna say self-test taken. Self-test taken is a dictionary, as you can understand from this curly bracket. And what we want to do, so let's check the formats over here. So whenever we call this test taken takes the name of the test as a key, and the item that it's going to give us is another dictionary. So let's go simple. What we want to do, we're going to pass the name of the test, which is course name, as a key, and at the end we want another dictionary. In this, the second dictionary, This is like the dictionary inside of a dictionary. In the second dictionary, we have two keys, which is score and the result. So let's create those keys. So this is exactly how you see over there. We're going to say score and column, and then we're going to enter this score we just calculated. And other key is result. And then what we would like to see is colon. We're going to put this result over here. Oh, sorry. We're going to insert this result over here. All right, that's it. We generated self-test taken was dictionary. We insert the key, and this key, the item that we are going to obtain with this key is also another dictionary, and this score and the results are again the key inside this new dictionary. So we updated self-test taken. All right, so far so good. So let's test if everything is working appropriately. So to test what you want to do, I give this option to you. Let's say student, okay, list 0, and I have a little typo over here. This is tests taken, but I generated over here like it test taken, I guess. Yeah, test taken. And let's say test taken. Okay, student test taken is 0. Now the first student didn't take any test yet. So now I'm going to say again the same student, take test. Now I need to enter which test we are going to take. Take test function. What does it take? This is a test. It's going to take a test object. I give this information in the question, and it's going to take the scattering of this student. So test object, a test instance or object, math. Let's say this student is going to take math, and then scattering of student list. Scattering of first student is math answers 0. Okay, and then at the end, let's again check this test taken statement, and as you can see, oh, we forgot something, guys. I just forgot to say if score divided by 100, because the pass mark was a percentage, but for the score I added 20. So let me run everything again. As you can see, the first student's score is 20, and the result is fail. So also let's add another test here. Let's say physics test, and this time instead of math answers, we are going to pass physics scantron for the first student, and let's see what happened. This student failed from all of them. If you go to part D, it says that calculate and print the average score in math test. To be able to do that, now we have to do this exact same procedure for all of these 10 students. All right, so to be able to do that, let's generate another for loop that represents to represent our 10 students. What we're gonna do, we're just gonna take these guys and we will call this take test function for each student. And again, I am updating those indices for I in range 10. So right now each student took this test. Let's go to part D, and it says, in part D, it says calculate and print the average score in math test. Let's say average score is 0, and then I'm going to find the real average. Again, for a for loop for I in range 10. So what do I need? I need, if I observe this test taken mathematics and score, it gives me the score. That's exactly what I want to do. Student list I dot test taken. This is a dictionary. If I put the name mathematics, or I can easily say that math dot course name. And in the second one, if I say score with a capital S, I can get, this gives me the student's score in math test, and average is gonna be sum of all of these, and at the end I will say that average is divided by 10. So let's print this average. I forgot to type in here for I in range 10. That was okay. The average score is 18. So the answer for D is average score is 18. Pretty bad because it's so randomized. Calculate and print the pass rate in physics exam. Okay, we will now calculate and print the pass rate in physics test. So I will kind of do something similar here. Let's say it's average, or let's say rates. So we need to generate an if statement here. If student list I test taken physics course name and result is equal pass. Then I'm going to increase this rate by 1. Then again, we have 10 students, so I would like to divide it by 10 again and print rate. If you want to see like a percentage, you can multiply with 100. So nobody passed, I think, physics course. 3, that's a very easy question. As you can see, this is about Fibonacci series. Let's read the question. There's a special relationship between the golden ratio and Fibonacci numbers. You know, Fibonacci numbers, each number is equal to the sum of previous two numbers. So this theory says that if you divide those numbers one another, such as 3 divided by 2, it gives us 1.5. Then 5 divided by 3, it gives us 1.666 ratio. And then if we keep doing this, like at the end, and when the numbers are really, really big, this series is converging to the golden ratio, which is a number known, this golden ratio exists in nature, in like when you look at the pattern on flower surfaces or like trees and etc. We would like to generate this Fibonacci series as long as the error between this ratio and the golden ratio is smaller than 10 to the power of negative 20. All right, let's start. So right now I have already put the golden ratio over here. I have already started. You're given a started list of Fibonacci series, so we're going to write our code below. That's pretty easy. Let's say what we want to do, while let's generate a ratio, And while this minus ratio minus golden number, and what we want to do, we want the absolute error. So let's say ABS gives us the absolute value of this difference, while this greater than or equal to 10 to the power of negative 20, we will keep building our Fibonacci series. So Fibonacci append Fibonacci minus 2 plus Fibonacci minus 1. Minus 2 and minus 1 over here means that um, sum to last two value. Minus 2 means the second last value, minus 1 means the last value. And let's go to the ratio. After we added this, we are going to define ratio again. This ratio is going to be Fibonacci minus 1 divided by Fibonacci minus 2. So this ratio is going to be updated, and then this is it's going to be recognized from here again. So that's the function we generated, but in part B says that print the last two numbers of Fibonacci series you build and their ratio. So what we want to do, while after everything is done, when we're out of this while, when we're out of this while loop, we would like to say print, let's say print the last two numbers of Fibonacci series. So Fibonacci minus 1 and Fibonacci minus 2. So these are two numbers. We would like to also print the ratio. So print and the ratio. As you can see, ratio is almost the same. If you would like to print all these 20 digits in this ratio, what you can do, generate a string, say percentage sign and dot 20f. It means that 20 digits after the period. We are going to say again percentage and ratio. Problem for me was so much fun to build this problem. So there is a definition in this problem. It says a subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order. That's the most important part of this question. Subsequence is part of this sequence that generated with those elements in the sequence, but you cannot change the order of these elements. So for example, ABD is a subsequence of A, B, C, D, E, F. As you can see, A comes first and then B, and then D comes after those. So this is like ABD is a subsequence of this. However, CBA is not a subsequence of this. Although each of them are in this sequence, C, B, and A, their order is different. Right now, we are given a word list. This is the word list. This is the word list is a list of words, and this is basically a poem, a part of the poem by Maya Angelou. And you have a long street. I basically generated this string just by adding some randomly generated characters. So what we want to do we are going to check how many of these words are subsequence of this long string. For example, as you can see, in is a subsequence, I is here, and n just here. But we don't want to do this manually. We would like to write a code. So again, the hints are given to you. You're given an empty list called subs. Which stores the word that are a subsequence. So in this list, I call sub here there's just a little typo. We would like to um, add the words which are subsequence of this long string. And there are also duplicates in the word list. If you have already added a word to list subs, keep searching the same word again. That's another thing, because there are two in. If we have finally found an in, you don't have to add this word into the sub list. And there's only a hint. You might want to use continue and break commands just to make your code faster. So that was kind of a challenge that I generated for my students. Whoever writes like computationally faster code, I was like giving them some gifts like books and stuff. So it was kind of a challenge that I like to like push my students a bit to generate more efficient algorithm, which is really important in today's standards, with today's problem with big data and everything. Let's start saying that for a word in word list. So let's say we are starting with in, okay? Uh, to write the code easily, I just consider an instance like in, and then try to think about like how can I adjust the algorithm, how can I adjust the code to make it work. So when you think about one instance, it really helps you to understand if code is really working. So what I want to do, so first, as you can think, I would like to check this I letter inside this long string, right? Let's say for j in long string, for j in long string. So I'm going to check the first letter of this a word is equal to, if 0 is equal to this j. After this is confirmed, then I'm going to check if a word 1 is equal to another j, right? So then let's start another in this to define this 0 and 1. Whenever this statement is correct, then we can increase the value of I. So let's say if a word I is right now 0, right? For each word, I starts from 0. This is what it means. We wrote this inside this for loop. If a word I is a word 0, which is I, is equal to this j in long string, then what we want to do, we're going to increase this I value so that we can check the second value. All right. And if what we want to do, so otherwise there is no other possibility to increase this I value. If I is equal to length of a word, it means that I found all the letters in this a word, in this word, with an order. With an order because I never start j from the beginning. J keeps counting, right? J never becomes 0 again. It's not like we keep the order. We still keep the order with that reason. So whenever this I is equal to length of a word, it means that we found this word as a subsequence in this sequence. So then we will say that sub append a word, and it means that we already found the word, so we don't have to look for, we will just we don't have to still keep going in this for loop. We can just say break. All right, so there was another condition. It says if this word is mentioned twice, like in and in, off and off, you don't have to check for off if you have already checked it. Let's say if a word can be found in this sub that we generated, we can say continue. It means that just pass looking for this, don't uh, execute the code below, just go to the second um, instance, which is the next word. All right, so I think that's it. Let's check this question. As you can see, this is the answer. In spite of war, hate, lilacs are at my gate. The glory just to live is so divine when left their eyes mine. All right, we did it correctly. Just to show you what happens if you don't insert this code, then you're going to print, like, again, the same. Now you're going to print multiple times of the same words because they're mentioned here like multiple times. So yeah, I really enjoyed writing this exam. I'm hoping that you also enjoyed solving these questions, and let me know if you have any questions. If you don't understand any part of this code, I can try to help you. The answer sheet might look a little bit different than here because I try to solve it from the scratch. So as you know, there is not only one exact solution for coding. You can generate and really enjoy this creative platform. Hope you liked it. Let me know if you have any questions. If you don't understand anything in the code, just ask me. If you're having trouble to solve it in a different way, I again would like to help you. See you next time.